All right, so let's kick it off with NTFS, which is the new technology file system. It's the foundational file system used across modern Windows environments. From a theoretical lens, NTFS introduced a robust and extensible metadata architecture, making it more suitable for enterprise environments than its predecessors like FAT32. It has built in security and support for access control lists that define fine-grained file permissions. Security scripters such as owner group discretionary access control lists, and EFS, which is encrypted file system for file level encryption tied to user certificates. You can even use iCalcs in order to manage your NTFS permissions through the command line interface. NTFS also supports journaling for resilience, ensuring that if a system crashes mid-operation, metadata can be recovered. In terms of performance, it employs B trees and indexed attributes for rapid lookup and scalability, which makes it ideal for large-scale deployments. Within security audits, you'll examine the ACL inheritance, privilege escalation potential, and audit flags, which are all essential for incident response and hardening Windows hosts. So Active Directory. Well, it isn't just about user logins. It's actually a security critical component of any Microsoft enterprise environment. Active Directory acts as a distributed hierarchical database backed by LDAP, DNS, and Kerberos. It enforces centralized identity and access management, which enables domain wide group policies, authentication, and role based access controls. Active Directory is composed of ADDS, which is the directory service for user and machine accounts, ADLDS for application specific schemas, ADCS for PKI and certificate management, ADFS for single sign on across federated services. And you can use PowerShell in order to automate provisioning. And this aligns with hardening goals, reducing misconfigurations, enforcing consistent access policies, and implementing the principle of least privilege. We also touch on group policies which enable you to enforce password complexity, disable vulnerable protocols, and script software deployments. Active Directory plays a central role in enterprise hardening strategies. If it's compromised, your whole domain ends up exposed. Now, there are multiple ways to manage file permissions across multiple operating system environments. File permissions are the frontline defense in any operating system. We have Windows NTFS, which permissions are granular. You read, write, execute, full control, and modify. Inheritance and security descriptors allow for structured delegation, but misconfigurations lead to privilege escalation. Administrators manage these via the GUI, but iCalcs and Takedown allow for a really awesome CLI control. For Linux, more specifically CentOS and Ubuntu, permissions are minimalistic. You have your read, write, and execute or RWX for user, group, and others. Commands like chmod and chown and lsl are essential for understanding how to manage them. You can also use your SUID, SGID for permission inheritance, StickyBit to protect shared directories, and access control lists that you can set through set F ACL for non-traditional use cases. OpenSense is a hardened network firewall and router appliance. It's based off of the hardened BSD, which is a security enhanced fork of FreeBSD. Additionally, you can fully manage it through its secure web GUI with built-in audit logs. So there's no command line interface required for routine tasks, but also you can use SSH or console access if you need to. It's even upgradable with its plugin system that supports features like Tor, Let's Encrypt, Wasai Agent, and ClamAV. So we're going to start off with our demonstration in our virtual environment. You should already have VirtualBox installed. But if you don't, do that before watching this video. The result of the lab is to have your host only and NAT adapters configured. Your OPNSense firewall and router should be fully configured with DHCP, have Windows installed, and Windows actually does have an internet connection that passes through the OPNSense firewall and router. All right. So assuming you have VirtualBox already installed and the extension pack downloaded, we're going to move on to setting up OpenSense. The first couple things you have to do though is you have to make sure that you have a host only adapter enabled with an IP address assigned and DHCP disabled. For your NAT, we're going to name it WAN, and we do want DHCP enabled on that one. Once that's done, you're going to create your FreeBSD virtual machine, adding the VDI to it as the primary drive. And then we're going to boot from that and install on the secondary drive, which will then later become the primary drive. Now that we have OpenSense set up and mostly configured, we're going to install Windows 11, but we're only going to be using a trial version of Windows 11 Enterprise with the networking disabled for now. Once it's all installed and you're booted in as the administrator, you can then shut it down, enable networking, and then boot back into it and configure everything else. We're going to finish it off with debloating it using Chris Titus Tech's debloater.